Welcome to the session on forces and motion, motion in 2 dimensions. The objectives for this session are to apply Newton's second law of motion, F equals ma, to vector forces and acceleration. Let's now take a look at Newton's second law of motion. The force required to accelerate a particle is equal to the product of the mass m of the particle and the acceleration a produced, so F equals ma. Let's take a look at some examples. A force of 1 Newton acting on a mass of 1 kilogram accelerates the mass by 1 meter per second squared. If a force of F newtons acting on a mass of m kilograms accelerates the mass by a meters per second squared, then F equals ma. This is also known as the equation of motion. Note that this equation can be used to solve problems involving vector forces which act on particles. Let's now take a look at some notation. In this version of the equation of motion, F equals ma, F and a are vectors. We write the acceleration as a 2-dimensional vector, pi plus qj meters per second squared, or pq meters per second squared, as shown. Let's now take a look at an example. A resultant force of 5I plus 8j newtons acts on a particle with mass 2 kg. Find the acceleration, bearing and magnitude of the particle. So let's solve this. Of course, we know that F equals ma. So, plugging in the values gives us 5I plus 8j equals 2, which is the mass, times the acceleration, which we are required to find. This implies that a, or the acceleration, is equal to 2.5I plus 4j meters per second squared. And it therefore looks something like this. We can find the size of a by using Pythagoras. So mod a equals the square root of 2.5 squared plus 4 squared. And therefore mod a equals 4.7. We also know that tan theta equals opposite, which is 4, over adjacent, which is 2.5. And therefore theta is equal to 58 degrees. So here's a summary of the key points. The bearing is therefore going to be 90 degrees minus 58 degrees, which is equal to 32 degrees. Now let's take a look at another example. The forces F1, F2, F3 and F4, as shown, act on a particle with mass 7 kg. Find the acceleration of the particle. So let's solve this. The resultant force is the sum of all these forces. So F1, as shown, plus F2, plus F3, plus F4, which equals 6I plus 2j. Of course, the resultant force is in newtons, as shown. Now the force equals ma formula gives us that 6I plus 2j newtons equals the mass, which is 7 kilograms, times acceleration, which of course gives us that a equals 1 over 7 times 6I plus 2j. Now let's take a look at another example. A particle of mass 7 kilograms is acted on by a force F equals pq. Given that the particle is accelerating at a rate of 2 minus 3 meters per second squared, find the values of p and q. So let's solve this. We have F equals ma, therefore pq equals 7 times 2 minus 3. And therefore, solving this gives us p equals 14 and q equals minus 21. This brings us to the end of this session. If you have understood its contents, you should be able to apply Newton's second law of motion, F equals ma, to vector forces and acceleration. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.